My name is Dr. Sarah Place. I'm an Associate Professor of Feedlot Systems at AgNext at Colorado State University. My background is in measuring enteric methane emissions, mitigating enteric methane emissions, and modeling enteric methane emissions from cattle systems. I developed the Dairy Fact tool, the feed additive calculator tool for lactating dairy cows. This tool can be used to assess your baseline enteric methane emissions, look at the impacts of feed additives on enteric methane emissions, but also animal performance and your margins in terms of income over feed costs.
So we're going to walk through the AgNext feed additive calculator tool, or FACT, for lactating cows. The first part of this tool up at the top is just a section for you to enter, if you so choose, information such as the date for later use when you print out the results. The second section is really the meat of the calculator. So all of these cells that are in blue are user-defined inputs that you can change. The first section up top is fairly self-explanatory, so it's information about the cow itself in terms of body size, how much she's consuming, the diet type in terms of how much NDF it has, etc. The key thing to point out here in this upper section is you have two options when you're entering milk prices. You can either enter a milk pool price in terms of $1 per hundredweight value, or you can enter individual prices for the components such as butterfat, protein, other solids, and that'll calculate a hundredweight price for you based on those inputs you enter. As we scroll down, the key part of this input section is the feed additive section. This is what's going to give you your outputs that compare to your baseline emissions and help you understand the economic implications and emissions implications of feed additives. The most important spot here is for us to enter something in the estimated impact of methane production. So for example, we could enter negative 30% here if we expect a feed additive that we are using to reduce enteric methane emissions 30% per cow. Right now, for ease of use, we're going to assume no impacts on the animal performance in terms of milk yield, milk fat, milk protein, or intake. But what we also want to make sure we enter is a cost for the feed additive. So right now we have about a 15 cents per head per day cost. We'll leave it right there. And we can also enter, importantly, a carbon price. This is referring to the price you would receive in terms of compensation for the reductions that you've generated from the feed additive. Here in this scenario, we'll enter $50 just for an example. The next section is the outputs. So on the left-hand side are both the outputs for the baseline scenario and the feed additive scenario, just so you can compare your production metrics and also the enteric methane emissions expressed in pounds, units, or in kilograms. We're going to focus in on these charts over on the right-hand side. So the top chart is just expressing total enteric methane emissions as pounds of CO2 equivalents per head per day. So we can note that when we entered our 30% reduction, of course, we had a reduction in methane emissions from the additive scenario compared to our baseline. As we keep scrolling down, another important part is basically our income over feed costs in the two different scenarios. So in this case, you'll see that our baseline had an income over feed costs of $18.11, and the additive scenario, $18.14. This is highlighted in this bottom line at the bottom in terms of a 4 cents per hundredweight difference. And this highlights in this particular scenario, given all the inputs that we entered, that we would have a net positive return of 4 cents per hundredweight, given the carbon price, the feed additive price, and the reduction that we received. Again, that's a quick overview of the AgNext FACT for dairy. If you want to learn more, including the user guide for this tool, please check out the website agnext.colostate.edu/dairy-fact.